Recording is also not on now. Okay, so assignment problem. Assignment problem. It's a special case of transportation problem with a square cost matrix. Okay, so normally we have supply centers here, supply centers, then you have a demand center, so we used to have supply centers and demand centers. Say supply center S1, S2 and so on. Demand center D1 and D2. And here it is used to be the supply, and here it used to be demand. Isn't it? Is it correct? Here it is C11, C12, C21, C22. That is cost of transportation. Here there is some demand, S supply S1, or let us say here in this case, for the assignment problem, the supply will be 1, demand will be 1, demand will be 1. So the summation is 2 on both the ends. So summation of supply is equal to summation of demand. This is a balanced problem, isn't it? Why this is a special case of transportation? Because here supply is also equal to 1, demand is also equal to 1. What we mean to say here is the assignment problem is used for allocation of, so assignment problem is used for allocation of resources to demands. Okay, so instead of having a transportation problem, or instead of having a transportation matrix, what we will do here is we will write like this. Here we will create a matrix like this: 1, 2, 3, 4, 5. So let me take 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So here we will have resources R1, R2, R3, R4 and R5. This is allocation A1, or machine centers, or anything, whatever you want: A1, A2, A3, A4, A5. Okay. Similarly, here it will be C11, cost of allocation C12, C13, C14, C15. Similarly, you can write all this, isn't it? So simply I'll write here C51 and C55. Okay. The only thing is the allocations will be made in the unit of 1, indicating that R1 will be allocated to A2, that is resource 1 is allotted to allocation 2 having a cost C12. Similarly, say if I make an allocation here, if I make an allocation here, if I make an allocation here, and if I make an allocation here, indicating that R2 is allotted to A1 having cost C21. R3 is allocated to A3 having cost C33. R4 is allocated to A4 having cost C44. R5 is allocated to A5 having cost C55. Okay, and total cost will be equal to T is equal to C12 plus C21 plus C33 plus C44 plus C55. Okay, these allocations may be varying. Now, if you remember, in transportation problem, number of allocations will be equal to number of allocations will be equal to what will be number of allocations in transportation problem? What should be the number of allocations in transportation? What should be the number of allocations in transportation problem, students?
M plus N minus 1.
Exactly, it will be M plus N minus 1, isn't it? But here, this is for transportation. This is for since it is an assignment problem. In assignment problem, number of allocations should be equal to n. And what is n? This is for assignment. What does this mean? This means that each and every resource is being allotted to each and every allocation. If it is not equal to n, if this is not equal to n, then it is degeneracy here. Okay. Did you get it? Students, did you get it? Is there any doubt up to this point?
No, sir.
Number of allocation equal to n, sir.
Yes, number of allocations equal to n. What does this mean? This means that, say, what are the number of rows? Number of rows are n. What are number of columns? Number of columns are n. If the allocations are 1, see, we are making what is the supply here? Let me go like this. What is the supply here? Supply here is 1. Here is 1, 1, 1, 1. So if you have made an allocation here, demand is also 1, 1, 1, 1, 1. So if I make an allocation of 1 here, this means that this will become 0. This will also become 0. Okay. So this will get eliminated. At the same time, this will get eliminated. Okay. That means if the number of allocations are n, it means that each row and each column is eliminated. See, if I cut the row and columns, all the rows and all the columns will be cut. If the number of allocations are n, you can count 1, 2, 3, 4 and 5. All the allocations are there in each row and each column. Correct?
Yes.
What does this actually mean? This actually means, like, for example, I have 5 subjects. Okay, correct? Let us take this to your understanding. For example, you have 5 subjects. Let us name them as, first was FMHM, correct? Then you have TE1. Then you have, what is the other subject? I
Com.
think com. Then what is the other subject? B triple E.
ICS.
The last one? Okay, ICS. And you plan that I will study only on Monday, Tuesday, Wednesday, Thursday, and Friday. No studies on Saturday and Sunday. Okay, so you need to allot one subject on one day. So if you make, say, FMHM here, T here, Com here, B triple E here, and ICS here. That means each subject is allotted to one day only, isn't it? This is simplest case. This is simplest case. I have simply allotted 1, 1, 1, 1, 1. Okay, but there will be certain constraints also associated with this. Like you may not have a lecture of Com on Wednesday. Then there is no need for studying Com on Tuesday because you won't be able to answer anything on Wednesday. But you are having class on Monday. So will it be good that if you study Com on Monday so that you can remember whatever is taught in the class, isn't it? So
Yes.
that way there will be certain constraints. Whatever you have studied, you want to revise it. So you want that particular subject should be studied on that day where I have a class. Okay. So there are certain constraints associated with it. So this was simple. Now I have said that there are constraints. So that is one, that supply and demand constraints, isn't it? So there are certain costs also associated with them. If I don't study Com on Tuesday, I may lose a marks that is on Wednesday if I have a test, isn't it? So there are certain costs associated with it. If you are losing marks, then there are certain problems associated with the marks. So this is the assignment problem, that you have to assign a subject on a particular day so that you can easily get good marks in your subject, as well as you can also remember what is taught in the class. You can also revise what is taught in the class. Is it clear? Is it clear now? Why the number
Yes,
of
sir.
allocations is equal to n? Is it clear now?
Yes, sir.
Each subject is to be allocated only to one day. I don't want to study it every day. Okay, so then it is an assignment problem. Correct?
Yes.
Is it correct, student? Sometimes you may say that, sir, FMHM is difficult, so I wanted to study it on 2 days. If you want to study it on 2 days, then it will be a transportation problem rather than being a assignment problem. Is it clear? Is it clear, students?
An assignment problem can be made a transportation problem, sir.
Yes,
Like
an
that.
assignment. What is a transportation problem is a assignment problem. Assignment problem is a special case of transportation problem. Assignment problem is nothing but a special case of transportation problem. The only thing is here the supply and demands are equal and is only equal to one. That is, only one resource is allocated to one machining center. Say for example, if you have 5 operators, if you have 5 machining operators, say machining operator, operator O1, operator O2, operator O3, operator O4, let us take 4 only, 4 operators, and you have 5 machines, say lathe, drilling machine, then you have a milling machine, okay, then you have a shaping machine, okay. So you have a lathe, drill, mill, and shaper. Correct? So these are 4 machines and these are 4 operators. Now, if you give an operator one, because you are paying these operator the salaries, isn't it? These
Yes.
operators are having salaries. These machines will have certain electricity cost associated with them. These machines will also have maintenance cost associated with them. These machines will also have overhauling cost associated with them. What is overhauling and what is the difference between overhauling and maintenance? Maintenance is when there is a breakage. Overhauling means like you have to oil it regularly, you have to clean it regularly, you have to put in some spare parts regularly. That is called overhauling. Okay. So there are certain costs associated with it. But if you see, the option is this operator can work on only one machine. He cannot work on two machines simultaneously. And on lathe also, you will have only one operator. You don't need two operators. On drilling also, you need one operator. Milling also, you need one operator. Shaper also, you need one operator. Similarly, these operators can work only on one machines. So this is a special case of transportation where we are using these problem formulation for solving the assignments. That is, we have to assign one operator to one machine. Like this, you can give the allocation. Okay, so these allocations can be in any manner. Okay, is it clear? Like operator 1 can be given lathe, operator 2 can be given drill, operator 3 can be given shaper, operator 4 can be given mill. Or operator 4 can also be given lathe and operator 1 can also be given mill. That can also be one case. Okay, so what we need to do is we need to make an cost, then there will be certain cost associated with them, C11, C12 and so on. So we have to minimize this cost, minimize the cost, so that each operator is assigned to machine. Okay, now what will happen if I don't give an allocation for this operator? Let us say I'm not giving operator 1 any work. What is the loss? Loss is that his productive hours, his machining hours, his manpower hours are getting wasted, isn't it? So this, as a production supervisor or a production manager, when you go for an industry and you're working for the allocation of your operators to different machine, you cannot have an laborer or a skilled person sitting idle, because his manpowers are expensive. You are paying for his salary, isn't it? So he should not be kept idle. He should not be kept idle. If he's kept idle, then we are using the cost associated with his salary. Got it? And if you are not allocating him any machine, at the same time some machine will also get idle, isn't it? If machine is idle, then your production is at a lower level. So production is also less, isn't it? That will hamper your cost of production. Is it clear now? Did you get the feel of what we are interested in doing for the assignment problem? Students, is it clear?
Sir, if we are having 3 operators on 4 machines, then same thing, sir.
Then it will be the same thing. The operator can work only on one machine. So if you have 4 machines and 3 operators will be working on one machine. So one machine will be kept an idle. Okay. One machine will be kept idle. So that is a problem. Okay.
Okay.
You cannot keep the machines idle. You have to keep the machines busy. That is the first thing. Okay. But there will be certainly some problems like that. As I said, there are balanced problem as well as unbalanced problem. So unbalanced problem means what? Unbalanced problem is what you said right now, that we have 3 operators and 4 machines. So definitely there is an unbalance, isn't it? For example, I'll give you an example of our college only. Say you have 3 labs, isn't it? You have thermal engineering lab, you have kinematics and dynamics lab, and you have MMT lab, correct? Am I
Yes,
correct?
sir.
Okay. Similarly, 4th year students are having CAD CAM lab and ICS lab. Similarly, 2nd year students have the MOS and MMS lab and PT lab. Okay. So if you see how many labs are there, 2nd year 2 labs, 3rd year 3 labs, final year 2 labs. Okay. So 2 plus 3 is 5, 5 plus 2 is 7 labs. Correct? Correct? These 7 labs are to be allocated to only 4 technical assistants. We have 4 technical assistants. Who are those? They are Krishna Rao sir, Ramu sir, then Surendra Reddy sir, and Raju sir. So we have 4 technical assistants. These 4 technical assistants have to work on 7 labs. So is this a balanced problem? Is this a balanced problem? No, this is an
No, sir.
unbalanced problem. So the assignment is to be made that each lab technician is allotted to one lab so that he can be sitting in that particular lab, maintaining the lab, collecting all the records, attending all the classes, taking all the work which is associated with that lab, taking care of the maintenance, taking care of the repair and various lightings, various other things. Whatever is the problem associated with that lab is to be taken care by the lab technician. So that is not a balanced problem. Similarly, but if you see in our case college, what happens is all the labs will not be conducted at the same time, isn't it? All the labs will not be conducted at the same time. So these people will be idle for some other work. So in those empty slots, we will be making them work in the other labs. Got my point? So if there is a balanced problem, that means you have enough operators and enough machines. If there is an unbalanced problem, then there will be certain. Hello, students. Am I audible?
Yes, sir.
Hello. Oh, sorry, I got a call and that's why I got disconnected. So what I was saying is, since we have these kind of allocations, we are making it a balanced problem. So next class we'll start with the this assignment problem. That is, we have a class tomorrow, isn't it? Yeah, we have a class tomorrow at 1:30. So 1:30 we'll start with the assignment problem. If there's any doubt up to this point, you can ask me now. Otherwise, tomorrow we'll take one problem. That way, it will be much better for you to understand. If there's any problem, ask me now. Students, is there any problem?
Sir, actually, it was given, right?
Sorry?
Assignment problem is a special case of transportation with a square cost matrix.
Yes,
So that is
square
why
cost.
I had asked, like, if the operators are less and the machines are more, then if
Yes,
the number of rows
if
and
this,
columns are not equal.
if the number of rows and columns are not equal, see that this I have shared one. Can you see the screen?
Yes.
Okay, see the first step, that there are different methods to solve this problem. There are enumeration method, simplex method, transportation method, and Hungarian method. So we are interested in this Hungarian method. Okay, so Hungarian method is developed by Hungarian mathematician D. Coin, is an efficient method for finding the optimal solution. In this, if you see the first step, there are certain steps associated with it. Say 5 steps are there. Okay, so these 5 steps we'll study in the next class. But for the first step, if you see, this is where you have a problem. If the number of rows are not equal to the number of columns, okay, if the number of rows are not equal to the number of columns, like you said, there are 3 operators and 4 machines. Okay, so if this is the case, and of dummy rows or column, the cost element in the dummy rows and columns is always equal to 0. Okay, that is, in all the elements, if in all the rows and columns, if the rows and columns are not equal, if it is not a square matrix, we have to make it by a square matrix by either adding the row or by either adding the column.
Sir,
okay, yeah.
we
So
add a dummy row or column when the problem is unbalanced. But if it is balanced,
yes, then there is no problem. If it's a balanced problem, then we'll find these then we'll solve it by the Hungarian method.
then we
Like
can
for your
proceed,
case,
sir.
what you said is, sorry.
If the rows and columns are not equal and the problem is balanced, can we proceed?
No, there will never be a case where there will be a balanced problem without having a square matrix. Why? Because as I said, each operator can work on only one machine. That is, supply and demand is equal to 1. Isn't it?
Okay.
Each operator can work on only one machine. So problem can never be balanced if it is not a square matrix.
Okay.
Isn't it? If it's a square matrix, then only the problem will be balanced. Because here supply and demand both are equal to 1. Isn't it? That is, only one operator can work only on one machine. If we say that an operator can work on 2 machines, then it will not be a balanced problem. It will not be a your assignment problem. It will go to transportation problem case. Okay.
Yes.
Is it clear then?
Yes, sir.
Any other doubts?
No, sir.
Anybody else who's having any doubt? If there aren't any doubts, then we'll continue in the next class. I don't think we'll be able to solve any problem here. Or let us just see through the Hungarian method how to solve it. Then we find an opportunity, or let's not go into this because this will make confusion. Better is we'll start in the next class. Okay. I think somebody has put in some chat. Please share today's class notes in the Google Classroom. Yes, I'll share it in the Google Classroom. I know for some times, for some days, I am not able to share the video recording, but today I'll hope that I have second half almost free. So in the second half, I try to club all those your recordings into one and put it as one notes in the Google Classroom. Okay. Any other doubts? Anything else, students, if you want to ask?